will mark it as this color, okay? And I will send the snapshot of this to the group, what topics been covered and what's not been covered. Okay, guys, I'm sharing it. Where is our SOC training group? Okay, let me open from device, and device is your draw.io. Okay, this is our beautiful dashboard on which we are working. So let's start with DMA. So you guys have studied in your graduation. What is DMA? Have you know anything about DMA, direct memory access?
So the memory will have address and we store the data inside the address, the memory,
Mm-hmm.
like that.
Okay. Okay, so let's talk about DMA. It's a very, what I can say, basic block. So, दिख रहा है screen? अरे WhatsApp किया है. So suppose this is a DMA engine. Basically, we call it as a DMA engine, okay? And DMA basically stands for direct memory access. So as the name suggests, that it would be performing some kind of a memory accesses, IPs, okay? So what DMA do, it have two ports or it can be more than two ports, okay? So like all other IPs, it will have a config space, okay? Like what I've told you, every IP have a config space and a data space. So this DMA also have the config space. Let's talk about this. Okay. So this config space is accessed by NAM. Which interface?
Yes, sir, IP base, sir.
APB. Good. So to start the DMA, we need to configure it first of all, right, through APB. So basically, in the configuration, what all things we will have? Let's expand it this way. That what is the source address from where we need to copy the data? What is the destination address from where we need to store the data? Okay,
In register.
not in register. Yeah, in these are the config registers. In the config register, we will program the source address, the destination address, the amount of data, how much amount of data you need to copy. Okay, basically these are the three basic needs for the DMA. Okay,
Okay, sir.
this one. So like you can see it over here, the DMA needs a source address from where it will fetch the data. So DMA have this AXI ports like this. DMA have those AXI ports like this. This is AXI. This is also AXI, okay? I'm not so good in drawing. I don't know why it's going back. Okay. Let's take a new box. I will put this box over here. This is the config space, okay? And these both are AXI. So in the DMA engine, what you will program? You will program the source address from where the data should be copied. You will Hariom ko de do Hariom. उस room में. You will have the destination address from where the data will be copied and from to where the data will be copied, and the total amount of data that you need to copy. Okay. So after the data completion, okay, and you will just enable the DMA. And the fourth point, you will just enable the DMA, that okay, start fetching the data. So when the DMA completes the data transfer, it sends an interrupt. It sends an interrupt. You already studied about interrupts, right? The completion interrupt. That okay,
Yes.
I have sent the data. My data transfer has been completed. So this is a very basic what I can say of our DMA. And in this slide that I have already shared with you, you studied about this deadlock, right? Rate limiter, routing algorithm. So this is the DMA controller. You can see DMA is the process of transferring data without the involvement of the processor itself. Till yesterday class, we were talking about ARM CPU that is taking control and accessing all the components. But DMA engine have the capability of transferring data without the involvement of the processor unit. It is used for transferring data to from input and to the output devices. A separate DMA controller is required to handle the transfer. The controller notifies the processor that it is ready for a transfer and indicate when the transfer is complete. So this is done through interrupt. Okay, how does it notifies? The controller notifies the DMA controller. How DMA controller notifies? It's through the interrupt. A typical SoC contains many DMAs for PCI, video decoder, Ethernet, SPI, etc. Okay, so this is the very basic of DMA that I have told you. So there will be many DMA engines present inside the there are many DMA engines present inside an SoC. Okay, so unlike so like other IPs also, I can put a small DMA engine over here in this figure as well. Okay, so this DMA engine will be communicating with the NOC and everything. So this DMA engine have the superpower, okay, to take control over the buses and start transferring the data from one IP to other IP. For an example, this is the DMA engine, okay, and this is the DMA engine, okay, and like what we have our address map at the bottom, this one, okay. So you program this 30 this address and the source, and you provide this address at the destination, and you want to copy 32 MB of data. Okay, so what you will do, from the CPU you will just configure the DMA registers. The DMA registers are configured through APB. Okay, what you will program, the source address, the destination address, and the amount of data to be copied. So in the source address field you will give suppose this, in the destination address field you will give this, and the amount of data you want to copy is 32 MB, and you will just press start. So what DMA will do, DMA will start fetching the data from our IP1 is the DDR, right, 32 GB. So it will start fetching the data from DDR and will copy the data towards the SRAM. So data will be coming like this towards the DDR, towards the DMA, and DMA will copy it to the SRAM. When the 32 megabyte of data has been copied, DMA sends an indications to the processor that I have completed the data transfer through an interrupt. This already I think we have taught you about interrupts. So this is the whole process of DMA transfer. I mean, this is enough for you as per your level of experience. We know we are not deep diving into the things. Okay. Any doubts regarding the DMA?
No, no.
Okay. समझ में आया कुछ? ठीक है? Now, my question from you guys. Okay. What will happen if suppose the transfer is incomplete?
Can you speak a bit louder, sir? I cannot hear you.
Okay, now it's okay.
Yeah.
So what will happen if suppose you asked to copy 32 megabyte of data and the transfer is interrupted in between and the transfer is not good? What will happen in that case?
We will lost the data.
That is okay, but how does the CPU knows?
So I think in the completion of interrupt, we will have complete signal to controller to know that the data transfer is perfect.
Yeah. So there are several interrupts, not only single interrupt. There are several interrupts that is coming out from each of the IP. One is the completion interrupt. The other may be non-completion interrupt. The other may be non-completion interrupt. Let's take a live example. Okay. NAM. For an example, you are a DMA controller. Okay.
Yes, sir.
I am the processor. I have the control over all of you, right? I am the king. I have control over all of you.
Yes.
And through the laptops and through the Ethernet, we are talking right to each other. And we are connected to different nodes of Ethernet, correct? So Ethernet is our knock, for an example, that is routing the voice into correct path. If I'm calling NAM, you are responding it back. So data is coming to you and you are giving the response back to me. Okay, NAM?
Yes, sir.
Just like the CPU also like us, that I am the CPU, suppose, and NAM, who, that, man, tree, jaya. So you guys are the IPs that is connected over the knock, that is connected over the knock, the Ethernet in the real time. Okay. So suppose, NAM, if I want to talk to you, I will call what? NAM is your address, right? So I'll call NAM. So you will just give me response. Say okay. NAM, you are in mute.
Yes, I'm okay, sir.
You are okay. So you have given me the response. It means if I want to address you something, you are giving me the response back. Okay?
Yes.
Woo.
Yeah,
Just give me the response. Not okay. Okay. If I'll call you Woo, are you here?
yeah, I'm here.
Yeah. So Woo also have given the okay response to me. That you have to give me a bad response. Okay. You should say I'm not okay. So
I'm not
if I
okay.
call that is giving me a bad response. So it means the word, the things that I'm sending to NAM is okay. NAM is listening to me. NAM and I have a proper connection. When I'm talking to Woo also have a proper connection. But when I'm talking to that is giving me a response, bad response. So on the AXI class, do you guys remember that we have okay response, slave error, decode error? You remember for the AXI, the
Yes,
bad
sir.
responses. So
Yes, sir.
that is the bad responses. In the APB, we have P slave error. So P slave error is the bad response. It means we are writing something and we are not getting a good response from that. Now talking about the DMA, suppose if I am the CPU, NAM is a DMA, Woo is DDR and that is SRAM. Okay? Okay. So and so what I'll tell, I'll tell NAM. NAM, I'll tell
Yes.
you what to
Yes.
do. You need to take some data from Woo, take, I think, let's talk about that way. You need to take some money from Woo. You need to take $1 million from Woo and give it to Dat.
Okay, sir.
Okay. I have instructed you. NAM, complete my work. Now you are my, what I can say, supervisor to monitor the things. So NAM, what you will do? I have given you the source address. The source address is woo, and the destination address is dat.
Yeah.
You need to take the data from woo and give it to dat.
Yes, sir.
Okay, so start transferring the data from woo to dat. When the transfer been completed, what I have told you to transfer 1 million rupees from woo to dat. If suppose 1 million is completed, Nam, what you will say? I am okay. I have done the transfer. Okay, so
Yes,
Nam,
sir.
I trust you. I have a trust on you. I am the CPU. I have a trust on you. So I will say, okay, Nam, you have done a great job. Thank you. But what will happen if that is not receiving the money? That says, I don't want to take $1 million. I have a lot of money. I don't want that. So what will happen in your case, Nam? What you will tell me? The bad response. You will tell me the amount of data that you told from to send from who to that is not responding. So it's a incomplete transfer that you had did. Okay, Nam?
Yes, sir.
Or you are communicating with Woo and you are communicating with that. Okay? Suppose if Woo is not ready, Woo is sleeping, Woo is not ready. First, you need to wake up Woo, correct?
Yes.
So if Woo is sleeping, Woo will give you the bad response. And in that case, you will also tell me transfer is not proper. So there might be several cases, Nam, in the case of a DMA in which the transaction or the transfer will be interrupted. I think this example gives you a best idea of a DMA controller.
Yes, sir. I can imagine how it works, sir.
Yeah, so there are a lot of interrupts inside a any of the IP. I'm talking about the DMA engine, so there are lot of interrupts. Okay, and each interrupt there is a each IP have a register called interrupt cause register. Which register? Interrupt cause. So each field of this interrupt cause register tells us what is wrong. So what will happen when CPU sends the interrupt? This is the CPU. It sends the interrupt. It goes. It goes. What it do? It goes like this and reads this interrupt cause register. Okay. This is the wire that is coming towards the CPU. The CPU will go and read what is the cause of this, whether the interrupt is, I mean, what causes the non-completion. So what the DMA IP will do, DMA IP will just go and uh, update this interrupt cause register by which the transfer is interrupted, and the CPU will read this interrupt cause register and will be able to know that, okay, this is the problem. Got it?
Yeah, got it,
Yes,
sir.
sir.
I I think you got a fair idea, man. How's you understood, man?
Yeah, I understand.
Tree.
I understand, sir.
Okay, tree. I have not involved you in that data transfer. I will involve you in some interrupt controller. Okay. So, guys, I mean DMA feature is. I think you are quite okay with this, correct? So I will talk with this error response. I will discuss about this as well in this class as we have some time left. Error response from unmapped and reserved space. Very easy
So
topic.
the
Yeah.
DMA is also a protocol.
DMA is not a standard protocol.
It's not a thing.
Everyone, yeah,
Yeah.
every company design its own DMA, but
Okay.
the basic functionality and the registers of the DMA are these ones only.
Okay,
Okay.
sir. Yes, sir. Yes, sir.
Now I think you guys have a better idea of an SOC, correct? Compared to previous week.
Yeah,
Yes.
correct, sir. We have
Yes,
Definitely.
sir. Sure.
a live view of it.
Okay, guys. So now let's talk about reserved space and unmapped space. Okay. Okay. So question to all of you. I have sent an AXI transactions from the CPU Listen to question properly, okay? I have sent an EXI transaction from the CPU on this address. On this particular address. Okay. Which, this is an AXI, this is an APB thing, right? I will write it down over here. This is of AXI and this is of APB space, okay? Control Z. Okay. I sent an AXI transaction to this address. Which slave it will target? 1, 2, 3, 4, 5, 6. Which one?
3, sir.
3. All agree? Everyone, that. Woo, man, 3, Jaya. Okay?
Yeah, the third one. Yeah.
Yes.
Yeah, simple, it's simple. The 330 is this one. So it's targeting this one. Suppose if I give 3, you will answer this. 50. Which slave it is targeting?
The 5th.
Very good. Now my question comes. What is this? Which slave it will target?
No.
Unmasked by.
Unmasked. No slave, sir.
Unmapped. Correct?
Yeah,
Yeah.
yeah.
So if it's unmapped, it will give you an error response. EXI error response. Okay? Got it? This is an
Yeah.
example of unmapped slave. So you will get an slave error response. Because slave doesn't exist on this particular address. Now my question comes. Again a new question. Okay, let me copy this. So I need not to type much. Okay. If I give you this address, which slave it is targeting?
The first slave.
First, yeah, the first one.
The first one. Very good. Which slave it is targeting?
Not him.
I think it's still unmapped.
Unmasked, sir.
It's still, no, it's not unmapped. It's a reserved space. It lies between these both things, right? It lies somewhat between these and this, right?
Yes, it lie between them.
Yeah, so it's a reserved space, what we can say.
Reserved space.
So you get a decode error for that. I think you got an idea, right? What is a unmapped and what is a reserved space? So let's take
Yeah,
for
I
this,
got this.
this example 1 0 0 2 3 4 6. If I give to 0 0 0 7, then it is a
Unmapped.
unmapped space. And if I give you something called okay 10 FF, it's reaching 10 FF. Suppose if I give you 11 FF, then it's a
Reserved
reserved space. It's a hole between the two 4 KB boundary, correct? It's
Yes.
the hole between the two 4 KB boundary. So in SOC, like what we have discussed several times, inside an SOC, we have discussed it several times that every IP have a data space and the configuration space, and our SOC have a full address map. of configuration as well as of data. Correct?
Yes, sir.
Okay. 1 minute. Ajit is calling. हाँ अजीत,
हेलो
चल गया वो टेस्ट?
सर, अब मैंने तो सुबह निकला है था और अभी देखा तो कनेक्ट नहीं हो रहा मेरा वीपीएन का इशू आ रहा है क्या?
नहीं चल रहा है वीपीएन तो यार. एक बार टर्न ऑफ करके ऑन करके देखो.
वो कह रहा है योर क्रेडेंशियल रॉन्ग क्रेडेंशियल बोल रहा है.
नहीं नहीं, टर्न ऑफ करो, टर्न ऑफ करके ऑन करो. अक्षिप को भी आया था ये परसों, नया नेटवर्क चेंज किया ना तुमने अभी, इसलिए.
ठीक है, चेक करता हूँ.
ठीक है.
ओके.
हाँ भाई. ओके. So every SOC have a data space and the address space, config space, what we say, and in the config space we have the reserved space, the unmapped space. So the error response will be coming from them. So the code error, slave error in the case of AXI, and in the case of APV you give a P slave error is the signal, correct?
Yeah.
In the
correct.
case of APV you will get that. Okay. So for records, I'll paste this as well in the blog. Okay. Now the basic, I mean, you got an idea of all the blocks of an SOC. These are the basic building blocks of an SOC. Now we will start with something called how does an SOC environment create, how does we verify the things? Because now if I will explain you the verification attributes and everything, so it would be much more easier for you guys to understand the stuffs. Okay.
Yes.
So now
yes.
any questions regarding these topics I have shared over WhatsApp as well.
So when we verify the SOC, we should focus on mapping and check the connection between them only.
50% of the attributes NAM is like that only. 50%. NAM you can
50%,
see
yes.
in an SOC, I have told you, if you want to verify this DDR at the block level, so this DDR can be easily verified over the block level, correct?
Yes.
But when you put it into an SOC, so whether you are able to access the DDR space from all the IPs, that is important for us. Correct?
Yes, sir.
So connectivity attributes are there in an SOC. Interrupt testing is there in SOC. Reserved space, unmapped space is there in an SOC. So when you will just look into this, key points. Just go through these key points. We'll go one by one over in the next class. But prior to it, just go over each and every one of it. Okay?
Okay, sir.
These are the all attributes that we used to cover. These are the SOC verification key points. So I'll cover these all PPTs in the next class. Okay?
Perfect, sir.
Yes, sir.
So 50% you are correct that okay, connectivity is the most important part. Second thing is you have to access each and every registers, each and every memory space you should cover, whether it's reserved, unmapped. So the ultimate goal should be you should not get a hang. Suppose if CPU sends a transaction that is not present in the address map, so that transaction should not hang, right? You should get some response back. For an example, if I'm calling someone's name, I will just stop sharing. Okay. If I'm calling someone's name, I'm calling Woo.
Yeah.
So now Woo responded. But suppose I call someone who is not present, Amy. Amy is not here, right? So Amy is unmapped for me for this meeting. I'm called Amy, but Amy is not responding me back. So that's a hang for me, right? I can process further if I get a response of the previous command that I sent. Same thing with CPU. CPU will process further if he gets the response back of the previous command. Okay. So you need to access each and every, whether it's unmapped, whether it's the non-existing region or anything. So what you guys should do, you should go and test everything. Okay.
Yes, sir.
Okay, guys. So I have another meeting at 11:30 after 3 minutes. So that's all for today's class. We'll meet tomorrow with SOC verification flow. Okay.
Yes, sir. Thank you, sir.
Thank you.
I see. Yes.
Yeah, man.
Tomorrow we actually in a holiday. I think it's may happen until next Wednesday because
I know. I
this is
know.
our big holiday.
I know, man. I know. But if you can find some time, half an hour itself would be good for me. You can join through mobile phone. 30 minutes you can give.
Yeah. Well, we'll try. But if I cannot choose, please, please,
Okay.
it's not easy for me. Yeah.
No problem. I mean, they can share the recordings with you and PPT and data you already have. Okay. If you have any doubts, you can post your doubt on the group itself. No issues. Please try to join.
Yeah.
I mean, it's good for you. Find 30 minutes. If not, then it's okay. Okay.
Yeah, I think it's good. Yeah.
Okay, guys. Thank you.
Thank you, sir. Bye, sir.
Thank you, sir.